In this video, we're going to look at vectors, how to add vectors using something called the triangle law of vectors. So here we have an example. OAB is a triangle, and the vector OA is positive A, and the vector OB is positive B. P is the point on AB such that AP to PB is 2 to 1. Write OP in terms of A and B. So what we do in a question like this, we say, right, I know the vector OA on the triangle. I know the vector OB on the triangle, but the vector that's missing is the side AB of that triangle. So I'm going to write AB here with an arrow, because vectors must have an arrow on it. So what we do, we put the point A, that's our starting point, and we go around the triangle. So we go from A to O, so we write that first, A to O, plus O to B, like so. Then because A to O is the opposite direction of OA, which is positive A, then AO must be minus A because it's the opposite direction, plus the vector OB, which is positive B. So therefore we can say that the vector AB is minus A plus B. Now the question says to work out the vector OP in terms of A and B. So I'm going to draw in what that vector is. So it's here. So it's this red vector here, if you like, OP. But we need to first of all work out what this vector AP is. Well, we've got a ratio here, 2 to 1. So that's going to be AP is 2/3 of the line AB, and PB is 1/3 of the line AB. So we can work out the vector AP by saying it's 2/3 of the line AB. Now that's going to be 2/3 times the vector of AB, which is minus A plus B. Now expanding the brackets, we get minus 2A over 3 plus 2B over 3 as the vector AP. So now that we've got that, we're in a process to work out this vector OP. So I'm going to say consider triangle OAP. Now we can say that OP, now let's do this in green, it's going to be the vector O to A plus A to P, like so. So we can say OP is the vector OA plus the vector AP. So what we can do is write this over here and say, well, we know that OA on our diagram was A. Now AP was minus 2A over 3 plus 2B over 3. So I'm going to write that in red. So we get minus 2A over 3 plus 2B over 3. That's what we found from before in the previous part. Now this is over 1. So we want to minus 2 fractions with the different denominators. So I'm going to make the denominators the same. Times that by 3, times that by 3. Hence we get OP is 3A over 3 minus 2A over 3 plus 2B over 3. And we can simplify this down to give me 3A minus 2A is simply A, so we get A over 3, and then we get 2B over 3, but don't forget it's 1A, so I'm going to write a little 1 here in red. And what we're going to do, we're going to factorize 1/3 out. So we get 1/3 of A plus 2B, and that is the answer. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. Okay, so for this question, we've got OPQ is a triangle, T is the point on PQ, for which PT to TQ is 2 to 1. So I think the first thing we're going to do is write in those ratios. So PT is 2/3 of the line PQ, and TQ is 1/3 of the line PQ. So if we look at our triangle now, we know that OP is positive A, OQ is positive B. So we don't know what this vector PQ is, the big side of the triangle. So let's start with that first. So we're going to go around the triangle. So it's going to be PQ is PO plus OQ. Now, PO is the opposite of OP, so it's minus A. Now, OQ is positive B. So now we know what the vector PQ is. Now, notice we need to work out the vector OT. Now that, I'm going to use a dotted line here, is this vector here. So what we need is the vector QT. So if we notice, we could work out what TQ is, because TQ is 1/3 of the line PQ. So that's 1/3 of the vector minus A plus B, which is minus 1/3 of A plus 1/3 of B. But don't forget, this is TQ. We want the opposite of that, which is QT. So we just change the signs around. So we get 1/3 of A minus 1/3 of B, because it's the opposite direction. Now I'm going to say, let's consider triangle OQT. So we're going to consider triangle OQT. Now going back to our diagram now, we want OT, so that's basically going to be OQ going this way plus the vector QT going around our triangle. So we can say OT is OQ plus QT. So OT is the vector OQ plus the vector QT. And we'll just go back to our diagram again, double check it. Yep. And then we can write the vectors in. So OQ is B. So we could write that in. So that's going to be equal to B. Now I'm going to write QT in red so it doesn't get confusing. So we get plus 1/3 of A. So plus 1/3 of A. And then we also have minus 1/3 of B. So now we need to collect the like terms. So I'm going to get B minus 1/3 of B. And then we've got 1/3 of A. But remember, with fractions here, this is over 1. Make the denominators the same. So we get 3B over 3 minus 1/3 of B plus 1/3 of A. And then we could simplify that down to 3B minus 1B is 2B. 2B over 3. And then we get plus 1/3 of A. So we can take 1/3 out as a common factor. So we get 2B plus A. And that is the vector OT.